Welcome to lesson 8.3, proving parallelograms on the coordinate plane. Now, what we're going to be doing is, of course, we're going to look at the coordinates of a quadrilateral, and using those coordinates, we are going to use our formulas, such as distance formula, slope formula, maybe even midpoint formula, to prove that the quadrilateral is a parallelogram on the coordinate plane. Now, we're going to have to do a little bit of a review first, now, because we're going to have to remind ourselves of those properties of a parallelogram before we get started. Now, there's 5 properties of parallelogram that you might remember. We might remember that we got 5 here. The 5 are: 1, opposite sides are parallel, opposite sides are congruent, diagonals bisect each other, opposite angles are congruent, and consecutive angles are supplementary. Now, you might be wondering to yourself, why is 3 in blue and 2 in red? Well, to do coordinate proofs, we can definitely prove that opposite sides are parallel, probably using that slope formula, right? We know how to prove things are parallel. We could show opposite sides are congruent. Maybe if we knew the side lengths, then we could do it. And diagonals bisect each other. I'm going to save that one for class, but we could use that. We could do that as well. Now, angles are tougher to prove on the coordinate plane, so we're actually not going to be dealing with these, okay? So if it's in red, we don't want to work with those. But these 3 properties we can prove on the coordinate plane. So let's put a little note there, okay? We're going to write a little note to ourselves. We can prove on coordinate plane. These other 2 properties, a little harder, okay? Can't prove. So, if you're looking at this diagram over here, if I asked you to prove that this is a parallelogram, there's a few options that you have, okay? You could show me that the opposite sides are parallel, and to do so, you would just show me the slopes of the opposite sides and show me that they're the same. So that's one option, right? Opposite sides are parallel. You could do that pretty straightforward. You could show me the sorry, I'm moving around too much. Okay. You could also show me opposite sides are congruent. Maybe if you found those side lengths, you could show me that those opposite sides are congruent. And diagonals bisect each other. Once again, you could also show me that diagonals bisect each other, but I'm going to leave that for you to figure out how you can do that. All right, but we could also show diagonals bisect each other. Now, in this lesson, I'm actually only going to show you one of these methods, but you can use any of these 3 to do the proof. We're going to talk more about that in class, but let me just show you how to do one proof on a coordinate plane, okay? So here's an example of a question, okay? Oh, lining that up. In this question, it says quadrilateral PSFT has these coordinates, okay, as you see here. We want to prove that PSFT is a parallelogram. So step 1, just like with the right triangles, is just graph your points. So we have negative 5, 1, that's our P. We have negative 2, 2, that's our S. We have negative 1, negative 3, all right, that's our F. And then we have negative 4, negative 4. And that's T. Okay, we're going to connect those together. And that does look like a parallelogram. Now, to prove it's a parallelogram, you can use any of those properties we talked about to prove it. Now, personally, just for this example, I'm going to prove that opposite sides are parallel. All right, so I want to prove PT is parallel to SF, PT and SF. Okay, I want to prove that these guys are parallel. And then I also want to prove that PS is parallel to TF. Okay, so I also want to prove PS is parallel to TF. And if I could prove finding that these opposite sides are parallel, then I know it's a parallelogram. So to do so, we're just going to recall what we did from level 7. We're just going to show the slopes are the same. So what I'd like you to do is first find the slope of PT. Now, I'm going to be lazy about it. You could use the slope formula, but I'm just going to count, okay? I'm going to be lazy, I'm just going to count. So I'm going to count from P to T. Remember, you always go left to right, so I count down 1, 2, 3, 4, 5, all right, and over 1. So it's down 5, negative 5, over 1. So the slope of PT is negative 5, all right? The slope of SF, once again, I'm just going to count 1, 2, 3, 4, 5. So I go down 5 and over 1. And so my slope here is also negative 5. So these 2 are parallel. So what I'm going to do is actually, and the way I'm writing, I'd like you to write too, right? PT is parallel to SF. Okay, just that's our first thing that we proved. We show that the slopes are the same. Now to prove that PS is parallel to TF, once again, we're just going to find these slopes. Let's find the slope of PS. So it's up 1 over 3. All right, so my slope of PS is 1 over 3. And the slope of TF, let's do the same thing. We're just going to count up 1 over 3. So up 1 over 3. And once again, we can see that these are parallel because of the same. So PS is parallel to TF. All right. So what we've done is actually proven that this is a parallelogram. We've shown that the opposite sides are parallel. Dope. Now, finally, that is basically the work that you have to show. We've shown the mathematics behind why we know this is a parallelogram, but we also have to write a conclusion. All right. So the final step here is just to write a conclusion, and it goes into this general template. In quadrilateral PSFT, we know PT is parallel to SF, and we know PS is parallel to TF. All right, and we've demonstrated why that's true. Therefore, PSFT is a parallelogram because, and we state the property here, opposite sides are parallel. All right, so remember, you want to state the property used. And you also want to state your evidence. All right, our evidence is that we know the opposite sides are parallel. The property that we used is opposite sides are parallel. All right, and that's just one way to do it. Now we're going to discuss other ways to do the same proof in class. All right, you could show opposite sides are congruent, and also you could show that diagonals bisect each other. But this is just one way to prove that this quadrilateral on the coordinate plane is a parallelogram. All right, let's try a second one. We're going to move on to a type of parallelogram. It's called a rhombus. Remember that guy? Now, once again, we have to review a little bit about our properties of a rhombus. So a rhombus is a parallelogram, right? So it's got all those properties, but then it has its special properties that you need to prove that it's a rhombus. So the properties here are all sides are congruent. Remember that property? Diagonals are perpendicular, and diagonals bisect vertex angles. Those are the three special properties of a rhombus. Now, once again, it's kind of hard to prove what we see in red, that diagonals bisect vertex angles. That's going to be tough. But it's going to be pretty easy for us to prove right here. All sides are congruent, right? We would just use the distance formula. We could show that all sides are congruent to each other, right? If I just found the length of AB, BC, DC, and AD, right? And I could also show diagonals are perpendicular, right? If I just show you that the slopes are negative reciprocals of those two diagonals, then I could prove it's a rhombus. So, how do we prove something's a rhombus? Remember, these are the two properties we can use. All sides are congruent and diagonals are perpendicular. So let me show you how it's done. We're given a quadrilateral, ROMY. We want to prove that it is a rhombus. Now, we're going to talk about different ways to do this in class, but I'm just going to show you one way. To do so, we first have to prove that it's a parallelogram. Okay, so let's plot our points. All right, step one is plot our points. So we have 2, 3. We have 5, negative 4. We have negative 2, negative 1. We have negative 5, negative 6. Negative 5, positive 6. I was looking at it like, what? All right. Just going to sketch out our rhombus. This does look like a rhombus to me. So we have R, O, M, and Y. So we drew it. Now the first thing we're going to do is prove that it's a parallelogram. And once again, you can use any method to prove it, but we first have to establish that it's a parallelogram. All right? That's step one. And we're going to use the method that we just used, that opposite sides are parallel. So once again, I want to prove that RY is parallel to OM. So let's write that out. RY. You know what? I like using the same colors. Don't ask me why, but I just do. Let's start off with the blue. So we're going to prove RY and OM. So RY is parallel to OM. All right. Oh. Sorry. we're going to find those slopes first, and then we're going to prove that ym is parallel to RO. ym is parallel to RO. All right? So we're just showing that opposite sides are parallel. Now take a second. I would like you to do this yourself. All right? Pause the video and show that the opposite sides are parallel. Find those slopes. You could do it by counting, however you like, but let's see if you get the same answer. So pause the video now and see that you can do this on your own. It's important. And then when you're done, check to see if you got it right. So pause the video now. I know you didn't pause it, but pause it. Okay. Pause it now. All right, so hopefully you have it written out just like this. We found that the slopes of RY and OM are negative 2 over 7. Both of them have negative 2 over 7, so that proves that RY is parallel to OM. And then we have the slopes of YM and RO, which also shows us that these are negative 7 over 2, so we show that those are opposite sides are parallel. So right here, we show that opposite sides are parallel. We know it's a parallelogram. Now the next step is to establish that it's a rhombus, right? That's what we're trying to do here. We're trying to show that this is a rhombus. So there's different ways to do this, but the way we're going to do it now is we're going to show one property of a rhombus, which is diagonals are perpendicular. Now you could show other ones, but we're personally doing that. So we want to show that RM is perpendicular to YO. All right, and if you look at that, it does look perpendicular. All right. So we want to show that these are perpendicular, okay? So once again, we could just use any method. Instead of counting here, actually I'll count. Let's count it, okay? That's the easiest way. You can use the slope formula if you don't like counting. Let's show that these are perpendicular. So first I'm going to find the slope of RM. So to go from M to R, I go up 1, 2, 3, 4. 1, 2, 3, 4. So my slope here is positive 4 over 4, which reduces to 1. Okay? Now let's find our other slope. We're going to go Y to O. So we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 over 10. Now remember, I went down, going left to right. So I got negative 1 as my slope. All right? That's negative 10 over 10. So as you guys know, these are perpendicular, so I can now state that RM is perpendicular to RO, YO. Jeez. All right, so that's how you prove it's a rhombus. First, you had to establish that it's a parallelogram. Then you had to show one property of a rhombus to show that it's a rhombus. And now we will go, now that we have all our math worked out, we're going to write out our conclusion. All right? So do me a favor. Ignore this. I'm going to change it. You'll see it differently on your sheet. Write it as follows. ROMY is a rhombus because opposite sides are parallel and diagonals are perpendicular. All right, and that's just restating the two properties that we proved. All right, so like I said, we're going to learn, this is one of those lessons where we're actually going to, it has to go along with the class, but this is just one way to prove that something's a rhombus. There are many other ways, but this is just one way that you've learned, okay? So, starting your independent practice, and my challenge to you is to see if you can figure it out yourself. What are the different ways to prove that quadrilaterals are both parallelograms and rhombuses?